Welcome to Sundar's lecture. This is third lecture, and let us see what are all the topics we have covered in the last class. So, in the last class, we have seen this very important topic, that is power balance in an electric circuit, as well as we have seen applying KVL and KCL in numerical problems. Right. So, what is power balance? Power delivered in a circuit will be equal to power absorbed. So, we have seen with this simple circuit. Now, today we will take little bit complicated circuit and we try to find current in all the resistors, and also I want to tell you one important concept. This concept will help you throughout this course, as well as it will be applied for all other courses in electrical circuits. This topic is very important. Right? Okay, fine. For that, we will take a circuit now. So this is the circuit, and in this circuit, uh, they are asking you to find all the current in resistors. Right? Now you see, not a complicated circuit anyhow. Uh, we have seen we have taken two loop circuit in the last class. Now you see, we have three loops here. See, this is first loop, or we will take fine. This is first loop, this will be second loop, and this will be third loop. One thing, it is not mandatory to choose this is first loop, this is second loop, this is third loop. That is up to you. You can choose anything as first loop, second loop, third loops. That is up to you, and it is not at all necessary to take any mandated procedure to tell that which is first loop, which is second loop. Fine, anyhow. So let us take this is first loop, this is second loop, and this will be third loop. So if we found that, what we have to do first, what I have already told you, you just try to put the current direction. So at this current directions, we are assuming, see, this is I1 and this is I2, and I am assuming this is I3. Right? So these three current directions are assumed by me. I have already told you this will be assumed by us. Right? Once you assume the current directions, now you put the current directions in all the resistors. Right? So this is I1, right? So I1 will be flowing in this direction 4 ohms resistor, and if you go like this in this direction in 1 ohms resistor, and in this direction in 3 ohms resistor. Right? So first I will draw that. So in this direction, that is I1. So, and then for 1 ohms resistance, it will be in this direction, and for 3 ohms resistance, this will be in this direction. That's all, right? So now we have drawn I1. Now you have to go to I2. So I2 is flowing like this. That means this is the loop. So where I2 will come, 1 ohms resistance in this direction, 2 ohms resistance in this direction, this 12 ohms resistance, it will be in this direction, right? So I will draw that. So you see, this is I2, and then this will be I2, and if I draw like this will be I2. That's all, right? Only three resistors are available, and you go to this loop, that means third loop. You see, I3 is flowing in this direction, from in this direction in 3 ohms resistor, in this direction in 12 ohm resistor, and in this direction in 2 ohms resistor, right? So I will draw that. So I3 is flowing in this direction, and in 12 ohm resistor it will be in this direction, and in 2 ohms resistor I will draw here to get a clarity, right? So now we have drawn all the current directions in the resistor. Now we have to write three loops for this KVL for the three loops. So you have to write a KVL for this loop, as well as for this loop. If you complete this, then we will find loop currents. Then we try to find all the resistor currents, right? So first I will write the loop current for this first loop. So loop current KVL for first loop, right? KVL for first loop. So if we write KVL for first loop, you can start at any point, no problem. I will start here. I will start here, then I will go in this direction, I have to go in this direction, then I have to come here, right? Because my I1 is like this. So first you start from this point, you are going in this way, you see you are going in this way and this current is also in the same direction. Then what you have to do? You have to put minus 4I1, that is voltage. Then you are going in this direction, you are traveling from minus to plus, then obviously you have to put plus that voltage value, that is 24. Then you have to go in this direction, you see again you are going in the same direction, I1 is also in the same direction. What you have to do? You have to put a minus 1 into I1. Then you have to go in this direction. You see I2 is coming opposite to you. So you have to put plus 1 into I2. Then you have to go in this direction. You see this is I1, right? I1 is in the same direction as you are going. So what you have to put? You have to put minus 3 into I1. Then you see you are going in this direction and I3 is coming opposite to you. So if it is opposite to you, what you have to put? You have to put plus 3 into I3. Then that's all, right? There is no other elements. You have started here and you have ended here, right? So you have to end here. So no other elements. So it becomes 0. Now you rearrange this sentence. So you see I1, you have this one, this is I1, this is I1. There are 4 I1s available. What you can do, if you add all these, 5 plus this becomes minus 8 I1. Then you have only one I2. Then you have only one I2. So you have to put plus 1 into I2. Then you have only one I3. So what you can do, you can put plus 3 I3, which is then one constant is available. So one constant, that will be 24 equal to 0. So now you rearrange this sentence. 24 is one side. So what you do, you bring all these terms to the other side. So if I rearrange and if I finally write, I will get plus 8I1. I have brought this 8I1 to the right hand side, minus 1I2 minus 3I3, which is equal to 24. This is expression number 1, right? So now you go for the second KVL for second loop. KVL for second loop. I'm explaining again because for a clarity we will do these kind of things for 1 or 2 lectures. Then it is simple to understand. Anyhow, so what I will do, I will start from this point. I will go in this way, come in this way, and I will stop here because my I2 is clockwise direction, right? Is in clockwise direction. So I will start this point from this point. So if I go in this way, I am traveling from minus to plus. So what I have to put? I have to put plus 12 volt. Then I will go in this direction. You see this current direction is same as I am going. So what I have to do, I have to put a minus 2 into I2. Then I will come in this way. You see again I am going in the same direction. So I will go fast now. I will go fast. So this will be minus 12 into I2, and you see that I3 is coming in the opposite direction. I'm coming in this way, but I3 is coming opposite to me. So what I have to do, I have to put plus 12 into I3. Then I have to travel in this way. You see I2, again I am going in the same direction. So that it becomes minus 1 into I2. And you see this I1 is coming opposite to me, right? I am coming in this way. This I1 is coming opposite to me. So what I will get, plus 1 into I1. That's all, right? I have started here and I have came to this point at last. So that it becomes 0. That's all. So now you see you will get 3 I2 terms, right? This is I2, this is I2, and this is I2. And if I simplify all these things, it will be 14 and 15, right? So minus 15 I2 will be there, and only one I1. So that it will become 1 I1. That's all, and only one I3, right? That is nothing but. So it becomes 12 I3 and one constant. So that will be 12 equal to 0. So if I rearrange this sentence, sorry, not sentence. rearrange the terms, I will get, I think I will keep this 12 one side. I will bring all other terms to the other side, right? So it becomes minus 1I1 plus 15I2 and then minus 12I3, which will be equal to 12, right? That is equation number 2. And I will go for KVL for third loop. You see, in this time I will go little bit faster since we have to manage time, right? So I will start at this point and I will come this way through this way and I will end here, right? So if I start from this point, I'm going in this way because my I3 is in this direction, so clockwise direction. So I will start this point. So if you see I3, I'm going in the same direction. What I have to do? Obviously, I have to put minus 12 into I3, and you see this is I2 is opposite to me. I'm going in this direction, but I2 is coming opposite to me. So what I have to do, I have to put plus 12 into I2. Then I'm going in this way. I3 is in the same direction. So what I have to put, I have to put minus. I have to put minus 2 into I3. Then you see I am coming in this direction, so that I have to travel from plus to minus in the voltage. So what I have to put here, obviously you have to put minus 10 here, right? This will be 1 minute. So this will be minus 10, and you have to come in this way. So you see, again I'm traveling in the same direction, so I have to put minus. So I have to put minus 3 into I3, and I have to travel in this way. You see, I1 is coming opposite to me. What I have to do again? I have to put plus 3 into I1. That's all, right? I have came to this point at last. So I have to put this should be equal to 0. Right now you rearrange the sentence, sorry, not sentence again. This is 3I1, only 1 I1 I think. So 3I1 will be there. I2 also I think there will be only 1. So that will be plus 12 I2. And you see there are 3 I3 terms. So minus 12 minus 2 will be minus 14 minus 17 I3. So minus 17 I3. Then I have one constant, right? One constant. That should be equal to 0, right? So if I just keep all these terms in the left hand side, I will bring this minus 10 to the other side. So what I will get? So I will get 3I1 plus 12I2 minus 17I3 which is equal to 10. Right? This is expression number 2. Sorry, not 2, this is 3. Fine. Fine. We have found 3 expressions, right? This is first expression, this is second expression, and this is the third expression, right? So you simplify these 3 expressions. If you simplify these 3 expressions, I will get what I am getting. I1 is equal to, I am getting 4.11 amperes, and for I2 I am getting 2.72 amperes, and for I3 I am getting 2.06 amperes, right? So these 3 are the loop currents. Now what we need to find? We need to find this resistor's current, right? Now you see all 3 values we are getting in positives, right? So if all 3 values are positive, then whatever the current directions we have assumed, that is correct. If the current directions, if these current values, loop currents are negative, then assumed current directions will be wrong. That we will see, right? Right, we have found this. Now we will take the circuit and we will draw only these three currents, right? For that we will take new page. See, I have taken the circuit again. This is first loop, right? This is first loop we have assumed. So what is the current in the first loop we have found? The first loop current, I will write it again. I1 and so these are all the three values we have seen, that is I1, I2, I3, right? So now you see current direction will be, this is I1 and we have assumed this is I2, and current directions this is I3, and you see we have to write the values now. You see this is I1, right? So I1 will flow like this. So in this resistor, this is I1, and I will write the values directly. That means 4.11 amperes, and the same current will flow up to this. So I will draw here too, 4.11 amperes. I will tell you why I am writing like this. I will tell you, right? So then I2. So I2 will flow in this directions. So in this resistor, I2 value will be, what is that, 2.72 amperes, as well as here also it will be I2, that means 2.72 amperes, right? Anyway, 1 minute. Okay, fine. Now anyway, I will draw this current value here so that you will understand. This is also 72 amperes. Now you see what is I3, that is 2.06. I3 will flow here, so that it will be 2.06 amperes, and it will also flow here, right? 2.06 amperes, and as well as you see this current will be 0.11 amperes, right? Now you see we have just written all the current directions of all the current values in the loops, right? You cannot write this 4.11 here. Why? Because this 1 ohms resistor is common to I2 as well as I1, so you don't need to draw like that. See that particular resistance. Anyhow, I will tell you now. So we have to find what is the current in all the resistors, right? So if you want to find, you see, first I will directly write here. I will write directly I through 4 ohms resistor, which means this 4 ohms resistor. You see, this 4 ohms is connected in only first loop, right? This 4 ohms is not related to second loop or third loop, only connected in first loop. So you directly write that I through 4 ohms will be I1, that is nothing but that will be 4.11 amperes. No problem with that. Anyway, now I have to go to this 2 ohms resistor. See this 2 ohms resistor, this is only connected in the second loop. It is not related to third loop, as well as it is not related to the first loop. So obviously, so this I through 2 ohms, there are two ohms resistors are available, right? You don't need to confuse this. I will put this as 1. So I will, this is first and this is second, right? So I through 2 ohms first will be connected in the only second loop. So that will be equal to I2, then that is nothing but 2.72 amperes. And I will go for this 2 ohms resistor. You see this 2 ohms resistor is connected only in the third loop. It is not related to first loop or second loop or first loop. So what I have to do, I have to write I2 ohms, the second ohms resistor will be equal to I3, that is nothing but it is 2.06 amperes. That's all, right? Now we have written all the resistor values current, and now we have to see, you see this 1 ohm resistor, very simple to understand, right? This 1 ohm resistor is connected to first loop as well as it is connected to second loop. So how I can find this current through this 1 ohms resistor? It is very simple. You see, you you see this is nothing but this point. I am assuming it as A. So I need to apply KCL at node A. So if I apply KCL at node A, for example, I will draw this as I through 1 ohms resistor. I am just drawing, right? This is 1 ohms resistor current. Now you put equal to symbol, you know the procedures now. So you put equal to symbol, you see this 4.1 amperes, 11 amperes is coming towards the node, it is coming towards the node. So I have to put that in the left hand side, 4.11, and you see this 2.72 amperes is going away from the node, right? So what I have to put, this should be 2.72 ohms amps will be in the right hand side, and also you see I through 1 ohms is also leaving this node, going away. So I have to put it in the right hand side, that it will be I through 1 ohms. So if I simplify this, so I through 1 ohms will be equal to 4.11 minus 2.72, right? So if I simplify this, I am getting I through 1 ohms will be equal to 1.39 amperes. That's all. 1.39 amperes. I need to find what is the current in 3 ohms resistor. This 3 ohms resistor. Now you see, I will apply KCL here. Simple, right? B. Make it as B. So KCL at node P. And also you see, I will assume my current direction. Now I will assume it in a different way, right? So you see, I will assume current direction I3 ohms in this way. This is assumed by me. Try to understand. So assumed by me. Now you put equal to symbol. You put equal to here. You see, this 2.6 ohms is coming towards the node, right? So what you do, you put 2.06 amperes in the left hand side, and you see this 4.11 amperes is going away from the node. You have to put it in the right hand side. So this will be 4.11, and you see this I 3 ohms is also leaving this node, right? So if it is leaving this node, then I have to put like this, right? I 3 ohms. So this is I through 3 ohms. Now if I need to find what is I through 3 ohms, so then if I bring this to other side, 0.2.06 minus 4.11 it will be, right? So what is this value? So I am getting I through 3 ohms resistor minus 2.05 amperes. Now you see, you are getting a negative value here. So what it actually indicating to you, the current direction assumed by you is wrong. It should not be in this way. It has to be in the opposite direction. You don't do anything. You don't do anything, right? What you do, you change this current to plus, and what you do here, you come here, and you change this current direction. This should not be like this. This is wrong. It should be like this. That's all. You don't need to find it again and again, right? It is not necessary, right? For your clarity, I have done like this. Anyhow, now we will go to find this 12 ohms resistor current. So if I need to find 12 ohms resistor current, I need to assume this node, right? There is 3 branches again. So what is that? KCL, I will write here. KCL at node C. So I need to assume the current directions, right? What I will do, I will assume this as I through 12 ohms resistor. So what I have to do now, I have to put a equal to symbol. You see this current, that is 2.72 amperes coming towards the node, right? So if 2.72 is coming towards the node, that you have to put it in the left hand side, and 2.06 is going away from the node. So what you have to do, you have to put it in the right hand side, and also this I12 ohms will also leave from the node, right? So what you have to do, you have to put that also in the right hand side, that is I through 12 ohms resistor. That's all. Now if I want to find I through 12 ohms resistor, then I have to bring this, I will keep as it is, then this will be in the other side. So if I simplify, So I am getting I through 12 ohms is equal to 0.66 amperes. Right? Now we have found all the resistor currents, right? Now we have found all the, now we have found all the resistor current. This 4 ohms resistor carries 4.11, this 1 ohms resistor carries 1.39 amperes, this 2 ohms resistor 2.72, this 2 ohms resistor 2.06, this 12 ohms resistor 0.66, this 3 ohms resistor carries 2.05 amperes, right? Now I will tell you one important thing and I will draw this diagram again. So you see here, we have taken the circuit and we have drawn all the currents in the same direction whatever we got in the previous line. Now you see, this is the topic I have told you already. This topic is very important. This will help you so many things. This topic will help you in so many places. So it is very important. So you try to understand this concept and it will be very interesting to see, right? So that topic, which is nothing but it is voltage between any 2 points. I will tell you the definition first. You just hear it, then I will explain you how it is possible. Voltage between any 2 points via any path will be equal. Just I will write that. So see, this is the definition. Voltage between any 2 points via any path will be equal, right? Now what I will do, I will assume the points in the circuit. See, this I am assuming it as A, right? I will take a different color so it will be good to see. So this I am assuming it as, this is also not correct. So this point I will assume it as A, this point I am assuming it as B, means this point, nothing, this point. So this point I am assuming it as C and this point I am assuming it as D, right? Now I need to find what is the voltage between V, A, B, right? Between point A and B, which means what? Between these 2 points. See, if you see any voltage between 2 points, so if it is like this, VAB, start, you just try to understand whatever I am telling now very clearly, right? Start from this point B and go to point A and measure the voltages. That's all. That is very important to understand, right? Now you see, this point is B. I need to go to this point. That can be any path, right? Let us be C. I will take this path now. Starting from this point B, I have to go in this direction and I have to go to this point A through this 2 ohms resistance, right? Let us we go like that. So start from this point, you go here, write the voltages value. You go here, you are traveling from this point to here, in this direction, right? So you start from this point, you go here. So you are going from minus to plus in the voltage source. So what you have to do? You have to put plus 12 and you see you are going in this direction and you are going in the direction same as the current. What we will do, if the current direction and the direction we are going is same, we have to put minus here. We have to put minus 2 into what is this? 2 into 2.72. So if I write like that, 2 into 2.72, and if I simplify this, I am getting voltage between VAB will be equal to 6.56 volt, right? This is the final VAB. Now I will tell you, right? Only we can go to A through this point? No. You see, start from this point, come here and go here. That is also VAB, right? That should be VAB. You see, I can travel like this, right? If I travel like, or else, you see, start from this point, come here, and you go to this point, come here, and then you reach this point here. That is also possible, right? So I will take this longer path now. So VAB, again, what is the thing? Again, I will take VAB. So what is VAB? Then you start from point B and you travel to A. That's all. So I'm getting to, I will start from this point and I am going in this way and I will go like this, right? So start from this point, I am going in this way. You see I am going in the same direction as this current. So directly what you have to do, you have to put minus 1 into 1.39, right? 1 into 1.39 you will get 1.39. That's all, right? Then I have to come here. Here also you see I am going in the same direction as this current. So what I have to put? Obviously I need to put minus 3 into 2.05. Fine. Then I have to travel in this way. See, I am going from minus to plus in a voltage source. Obviously I have to put plus. That voltage source value is 10. Then I have to travel to this point like this, right? So if I come like this current is coming opposite to me. If it is opposite to me, what I have to put? I have to put plus 2 into 2.06. That's all, right? Now, if you simplify this, you will get VAB will be equal to 6.58 voltage, right? 6 point. Anyhow, there will be some 0.01 or 0.02 error will come because we have not used the full terms, right? This is 0. This would have been 0. Sorry, 2.05678 like that, right? Anyway, right now we will take a different path again. You see, we will take like this. So this is again VAB, again VAB. I may choose this path, right? Start from this point, go here, and you can directly reach here. That is also VAB, right? So start from here. So you go in this direction. So the current, you are traveling the same direction as this current. Then obviously you have to put minus 1.39, right? Directly I am writing 1 into 1.39, I will get 1.39. Then you have to travel in this way. So what is this? If you go like this current is coming opposite to you. So what you have to put? You have to put obviously plus 12 into 0.66. And if you simplify these values, you will get VAB will be equal to 6.53 volt. At 0.05 or 0.1 values, some error will come, no problem. Anyhow, now you see, I have traveled this point to here, and then I have traveled this point to here via this path, and I have traveled from B to A through this path. Now you see, I can also travel, start from this point, you go in this way, come here, and you go here, and you can reach point A, right? You see, there are so many ways to reach point A from point B, right? So I will take this path also. Let us verify everything in the circuit. VAB again, which is equal to, you see, start from this point, come this way, and I'm traveling from plus to minus here, right? So plus to minus, then what you will get? That should be minus 24. You have to understand. That should be minus 24, and you come in this way. You see, I am coming in this way, but this current is opposite to me. So what I have to put? I have to put plus 4 into 4.11, right? Then I have to travel in this way. You see, I am traveling from minus to plus in the voltage source. Then obviously I have to put plus 10. Then I have to travel in this way. You see, again I am going in this direction, but current is coming opposite to me. So I have to put again plus 2 into 2.06, right? So now you see, that's all. We have reached the point here. After reaching point here, you don't do anything. Then if I simplify this value, this is coming as 6.56 voltage. You see, how interesting is this, right? That is why I am telling from the beginning, this electrical circuits, it's very important, very interesting topic. You see, this is the definition we have given, right? What is that? Voltage between any two points via any path is equal, should be equal. And you see, we have taken some points like VAB and we have traveled in different paths and we are getting all the values as around 6.56 is the perfect value. Anyhow, some errors will come. No problem. So you try to understand voltage between any two points. I will repeat it again and again. Why I am doing this? Because while solving some other techniques, we use this concept. And you try by yourself, what is the value of VAC? If it is VAC, then what you have to do? Start from this point, reach A. You can reach like this. And or you can go in this way to here. You can go in this way to here. Or you can come here, come here, come here, and you go in this way to reach C, reach A. So many ways. And if you find anything like this via any path, this concept will be perfectly applicable, right? Okay, fine. Thank you. We will see different topics in the next class. Let us we take current sources, right? We have seen with voltage sources, and we know to write the KVL expressions now. And while writing the KVL expressions, and at last we have found what is the loop currents and then what is the resistor currents, what is the current flowing in each resistors. That is also we found, and we know now what is voltage between any two points and power balance. Up to that we have seen. And in the next class, we will take current sources. Then we try to solve the problem using KVL and as well as KCL. KCL will come. No problem. Right? Thank you.